Before we get started on the temperature and density worksheet, I wanted to go over something really quick I forgot to mention that I usually draw out in class. Okay, so when we're dealing with density calculations, we get the mass of something by going to the scale. Okay, so we either go to a triple beam balance or we go to the electronic scale, and it gives us the mass in grams. Okay, volume is a little bit different. Okay, so if we're measuring the volume of a liquid, we have a graduated cylinder. Okay, we're going to do this with one of our lab assignments. So say our liquid goes up to right here. And say that's like 20 milliliters. We read from the bottom of the meniscus. Okay, it's the curvy part. It makes like a little curvy line like that. So that is going to be one way we find the volume of a liquid. If we're looking at a volume of a substance, like a solid. Okay, so say we're looking at the volume of a solid. Well, if it's a prism, you're going to do length times width times height to find the volume. If it's a cylinder, you're going to do pi r squared times the height. So that's a prism. This is a cylinder. You're not really going to come up with anything else with that. Now, what if it's an irregular shaped object like a rock? Okay, and this is going to be on your test, so make sure you pay attention to this. Okay, so say I have some water initially in a graduated cylinder, and say it's initially at 20 milliliters. I drop a rock. Say my rock looks like that. It's like a gingerbread man. Okay, now I drop it in there, and I see that the volume goes up. Okay, so I see it goes up to 35 milliliters with the rock inside. Okay, so my rock is inside. Okay, that's called water displacement. Okay, so the way you get the volume of the rock or the irregular solid is you subtract. You do 35 milliliters minus 20 milliliters. Is equal to 15 milliliters. So that's how you get the volume of an irregular shaped object, is by water displacement, okay? And you will have to do that on your test. So say I get into a bathtub that's full of water, okay? What's gonna happen? Well, some of that water is gonna flow out, okay? The amount of water that flows out of the bathtub is going to be equal to the volume of your body, okay? So just keep that in mind. You need to make sure you know what water displacement is. Okay, now let's go through our temperature and density worksheet. Okay, first section. We're going to convert Fahrenheit to Celsius. So degrees Celsius is equal to degrees Fahrenheit minus 32 over 1.8. So it's going to be 62 minus 32 all over 1.8. So it's 16.666 degrees Celsius. Next one, I'm going Kelvin to Fahrenheit. In order to go from Kelvin to Fahrenheit, you have to go through Celsius. So degrees Celsius is Kelvin minus 273. I gave you that formula. So we're going to do 315 minus 273, and you should get 42 degrees. Okay. Now from there, we're going to go to Fahrenheit. So degrees Fahrenheit is equal to 1.8 degrees Celsius plus 32. So I'm going to do 1.8 times 42. plus 32. So 1.8 times 42 plus 32 is 107.6. Okay, now I want to convert Fahrenheit to Kelvin. So remember, in order to go between those two, you have to go through degrees Celsius. So I'm going to convert Fahrenheit to Celsius first. So degrees Celsius is equal to degrees Fahrenheit minus 32 all over 1.8. Okay, so we're going to do 2,500 minus 32 all over 1.8. Sorry, I keep hitting my camera. So 2,500 minus 32 divided by 1.8 is 1371.11. That's going to be degrees Celsius. And if I'm going to Kelvin, Kelvin is equal to degrees Celsius plus 273. So I'm just going to add 1371.11 plus 273. And I get 1644.11. That's going to be Kelvin. Okay. Okay. So in this set right here, we're going to be using our MDV triangle. Okay, in this section. So keep that in front of you as you're working. Okay, it says silver has a density of 18.3 grams per centimeter cube. What is the mass of 0.165 centimeter cube of silver? So this is my density and this is going to be my volume. Okay, so I'm looking for what is the mass. So I cover up mass. Density times volume. Okay, so your density is 18.3 and your volume is going to be 0.165. Multiply those two numbers together. So you get 3.02 grams. Okay, next one, it says find the density in grams per centimeter cube. If I have 7.25 liters, which is going to be your volume, and a mass of 4.225 grams. Now we have to be in milliliters whenever we do this. So we're going to use our King Henry died by drinking chocolate milk. Okay, I'm in my base unit and I want to get to milliliters. So we go 1, 2, 3 places to the right. So we need to move this 1, 2, 3 places to the right. So to find density, it's going to be mass over volume. Cover the D up. Mass over volume. Okay, so your mass is 4.225. Your volume is 7250. Okay, and I'm going to divide those two numbers out. And you get 0.583. Grams per centimeter cube. Okay, next one, it says a rectangular piece of wood has the dimensions 3 centimeters by 2 centimeters by 11.25 centimeters. And it has a mass of 12.62 kilograms. What is the density? Okay. So density is going to be mass over volume. Okay. To get our volume, a block of wood is going to be a prism. So we're going to multiply those. So 3 times 2 times 11.25 gets you 67.5 centimeters cubed. Okay, centimeter times centimeter times centimeter gives you centimeter cubed. Now, I have to be in grams. Okay, so I'm in kilograms. So, King Henry died by drinking chocolate milk. I have to move it 1, 2, 3 places to get to grams, my base unit. So this is going to be 12, 6, 20. Okay, so we're going to do 12, 6, 20 divided by 67.5 and I will get my answer. So 12,620 divided by 67.5, and you get 186.96 grams per centimeter cube. Okay, so I'm gonna go ahead and redraw my triangle up here. Okay, it says NaCl has a density of 4.3 grams per centimeter cube and has a mass of 35.22 grams. What is the volume? Okay, I don't have to do any conversions because I'm in grams per centimeter cube and grams. So volume is going to be mass divided by density. So it's going to be 35.22 divided by 4.36. Put that in your calculator. And you get 8.08 centimeters cubed. Okay, kerosene has a mass of 3.68 kilograms. Okay, so since I'm in kilograms, I'm going to have to convert. It has a density of 9.62 grams per centimeter cube. I want to find the volume. So volume is mass over density. Okay, kilograms. To go from kilograms to grams, we have to convert. Okay, so I have to go 1, 2, 3 places to get 1, 2, 3 to my base unit. So I'm going to move this over 3 decimal places. So I get 3680 grams. Okay, my density is 9.62. And so I'll put that in the calculator, 3680 divided by 9.62, and get 382.54. A bar of iron is 15.2 by 14 by 21.3 centimeters. So we're going to get our volume by multiplying all 3 of those together. So 15.2 times 14 times 21.3, and you get 4532.64. Okay, and it has a mass of 9123 grams. What is the density of the bar? So density is mass over volume. Okay, so your mass is 9123 grams. We don't have to convert that. Divided by the 4532.64. You should get 2.01 grams per centimeter cubed. Next one, lead iodide has a density of 2.74 grams per centimeter cube. What is the mass of 85 centimeters cubed of this substance? So if I'm looking for mass, I'm going to cover up mass. So you get density times volume. Okay, so your density is 2.74. Your volume's 85. So we're going to multiply those together. So 2.74 times 85, and you get 232.9 grams. Number 8, it says, what volume would be occupied by 8.53 grams of a substance whose density is 2.54 grams per centimeter cube? Okay, so I'm looking for volume. So I'll go up. Volume is mass over density. Okay, our mass is 8.53. Our density is 2.54. So I'm going to do 8.53 divided by 2.54, and you get 3.36 centimeter cubed. Ammonium dichromate has a density of 2.28 grams per centimeter cube and a volume of 253 centimeter cube. What is the mass? So if I go up to the top, mass is density times volume. Okay, so our density is 2.28. and our volume is 253. So 2.28 times 253, you should get 576.84 grams. Okay, on to the last few questions. Okay, let's just go ahead and redraw our triangle like we always do. So gold has a density of 7.28 grams per centimeter cubed. What is the volume? Of 2.13 kilograms of gold. Okay, so I see this kilograms. So if I see kilograms, I have to convert it to grams. So I'm going to move it 1, 2, 3 places to the right. So it's 2130 grams. So if I'm looking for volume, I cover V up, is mass over density. Okay, so it's going to be 2130 over 7.28. Put that in my calculator. Okay, so I get 292.58. And we're in centimeter cube. Bismuth has a density of 6.7 grams per centimeter cube. What is the mass if I have 3.28 centimeter cube? Okay, so I'm looking for mass. Mass is density times volume. Okay, so your density is right there, 6.70. And your mass is, your volume is 3.28. So we do 6.70 times 3.28, and you should get 21.98 grams. Okay, last two. Okay, it says first of 3 identical tanks, and one has water in it, the second has carbon tetrachloride, the third has mercury. The dimensions of the 3 tanks are 4 by 4 by 3. So 4 times 4 times 3 is 48 centimeter cube. Let's go ahead and calculate that volume. Okay, it says what is the mass in grams of each of the contents of the tank? The density of water is 1, the density of carbon tetrachloride is 1.58, and the density of mercury is 13.55. So this is just 3 different questions. So mass is density times volume. Okay, so we're going to do 48 times 1.00. So you got 48 grams of water. Carbon tetrachloride, you got 48 times 1.58. So 48 times 1.58 is 75.84. And carbon tetrachloride is that. And mercury, you got 48 times 13.55. So it's 650.4. Symbol for mercury is Hg. Okay. Last question. 30 grams of each of the following acids is needed. The mass will occupy what volume in milliliters? Okay. So we're looking for volume. So we go up to our triangle. Volume is going to be mass over density. Okay. So I have 30 grams of each of them. So we're going to do 30 divided by 1.639. I'm going to do 30 divided by 1.834. And I'm going to do 30 divided by 1.251. And I get 3 answers. So we're going to do 30 divided by 1.639. Get 18.30. And we're going to be in milliliters or centimeter cube, same thing. Okay, so next thing we're going to do is 30 divided by 1.834. I get 16.36 milliliters. And then I'm going to do 30 divided by 1.251. And I get 23.98 milliliters. Okay, so you can see that the less the density is, the more volume it's going to occupy. Okay, so anyways, that is your temperature and density homework, and hopefully this was helpful me going over more problems with you. Thanks, and have a good day.